Okay, so we're continuing with definite integrals. Okay, we're just practicing today. So it says evaluate the following definite integrals. So starting with number one, we're basically going to be doing the same thing we did with derivatives, but in the reverse order. So we start off with the function that we have. Then we are supposed to rewrite, integrate, and then simplify, and then we can evaluate our integral. Okay, so that's what I'm going to do first. 1 to 4, 3x, I don't need to rewrite that one. But this one here, if I switched it to this, rewrote it like that, and took my antiderivative, when I add 1 to the power and divide by the new power, that's going to cause issues. Okay, that's because when we have this 1 over x, from our derivatives, you should remember that 1 over x is the derivative of natural log is 1 over x. So the antiderivative of 1 over x is the natural log function. Okay? So when we take the antiderivative here, we're going to get 3x squared, add 1 to the power, divide by the new power, minus 2 natural log of x, and we're going to evaluate it from 1 to 4. Okay? So first you plug in your upper limit, so you get 3 times 16 over 2 minus 2 times the natural log of 4. Minus, and then you plug in your lower limit, so you get 3 times 1 over 2 minus 2 times the natural log of 1. Okay, now we simplify. So 16 divided by 2 is 8, so this is 24 minus 2 natural log of 4 minus 3 halves minus, and 2, the natural log of 1 is 0, so this is 2 times 0, which leaves me with basically 24 minus 1.5 minus 2 natural log of 4, which gives you 22.5. And you could do log properties here where you can move this coefficient up here if you wanted to and make it 4 squared and do the natural log of 16. But that's basically as far as you can go unless you put it into a calculator. Okay, so definite integrals, this is the area under this curve from 1 to 4. Okay, really very simple. All right, second one, same thing. Okay, so is there any rewriting I can do? No, not really. Okay, so we're going to go straight to finding the antiderivative. Actually, let me put this underneath. So the antiderivative of cosine is sine x, plus the antiderivative of 1 is x, and we're evaluating it from 0 to pi. So remember, we're still doing this using this equation from a to b of f of x dx equals capital F of b minus capital F of a. This is basically how you evaluate a definite integral. So that's what I'm doing here. Got to plug in your upper limit first. So it's sine of pi plus pi minus the sine of 0 plus 0. So you gotta know your unit circle. Sine at pi is 0 plus pi minus the sine of 0, which is 0. So your answer is pi. This equals pi. That's it.